In this lesson, we're going to talk about the sensor functionality. Before we can get to the sensor, we're going to have to discuss this rebuild symbol that you've seen at the top of the engine for motion assembly since the beginning. If we look into this, we find that the rebuild symbol is caused by a rebuild symbol that's on one of the parts. And if we open this part in its own window, we can see that the rebuild symbol is on one of the features. And this feature has a lock in front of it, and the yellow freeze bar is underneath it. The freeze bar was introduced a couple of releases ago, and it allows you to freeze a portion of the feature manager so that the features don't update. In this case, the feature that's being frozen is a mirror feature that references an external part. So even if a change occurred in the other part, this part would not update because of the freeze bar being below it. If I drag the freeze bar above the feature, then the rest of the features in the tree fail. This is not a situation we want to have happen, and indeed, once it has happened, there's not any way to undo it. You can't just hit undo and get your features back. So what I have to do in this case to set this part right again is go to File, Reload. What this does is essentially shuts down the existing part without saving any information, and then reloads it. So I'll click on OK. And we should be good to go again, but we're stuck here with the rebuild symbol. The rebuild symbol in this case is caused by the combination of the external reference and the freeze bar. I consider that to be a bug that's been systematically built into the software, and I'd like to see it fixed at some point because it's going to show up at the top level of every assembly that this component is in. The reason why we had to discuss the rebuild symbol was because as we apply sensors, SOLIDWORKS may ask us to update the assembly if it sees a rebuild symbol at the top of the tree. Let's go ahead and create a new sensor. We'll right-click on the Sensors folder and add sensor. If the sensor folder is not there, go to Tools Options, and in the Feature Manager, make sure that the Sensors folder is set to show. If it's set to automatic, it will only show if it has sensors in it. So you need to set it to show in order to create sensors. So let's right-click again and say Add Sensor. SOLIDWORKS is asking us if we want to rebuild the document because of the rebuild symbol. And now let's talk about various sensor types. A sensor is a flag that SOLIDWORKS will display if a value is in a certain range or equal to a certain other value. And you can have sensors for simulation data, mass properties, dimensions, interference detection, measurement, or proximity between parts. In this case, let's use interference detection. And let's not do it for the entire assembly. We know that there are interferences within the assembly. Let's delete this selection and zoom in to select the rocker arm and the camshaft. I'm able to select through this transparent part. If you didn't want to select through it, you'd hold down the Shift key, and then any selection would be of the valve cover that's on the top. This setting, I'm going to have to exit sensors here to show this, but the setting is found under Tools Options. We have to look at the Display Selection page. There's an option here that says Enable Selection Through Transparency. When that's turned on and you have a transparent part, what you're going to select by default is the part behind the transparent part. If I hit Escape to clear the selection, I can hold down Shift and select the transparent part itself. If the setting is set up the other way, then the Shift command works the other way. If Enable Selection Through Transparency is turned off, then you will by default click on the valve cover. And to get through to the rocker arm, you'll have to use the Shift key. Let's get back to the sensors. Right click, add sensor, rebuild. Notice the rebuild doesn't take away the symbol regardless of how many times you rebuild. Interference detection, we're going to clear selections, select the rocker arm and the camshaft. You'll remember some of these options from our previous dealings with interference detection. We want the alert to notify us if the value is true. So if there is an interference between those two parts, we want to know about it. So let's click on the green check. And now let's take a closer look by using a section view. We'll section right through the parts in question, and we'll accept this. Now we'll zoom in here, and what we're looking for is if this lobe intersects this part of the rocker arm. Right now the sensor just has a rebuild symbol on it, but if we move it slightly, we leave it in this position, we come up here, SOLIDWORKS is telling us that the interference has detected an alert. This is one of the ways in which sensors can work. Again, the other types of sensors that you can have available for you are mass properties, simulation data. This would mean if a stress value gets beyond a certain point, then you would want to know via a sensor flag. Mass properties, so a volume of a part gets beyond a certain point. Dimension, you could put a reference dimension on, and if that driven dimension is changed to within a certain range, then you could have it trip a sensor. Interference detection, we've just demonstrated. Measurement would be some sort of non-dimension measurement, so it wouldn't use an actual dimension, it would just reference two items. And proximity would be the proximity of one part to another. If the proximity between two parts became less than a certain value, then you could have that trip a sensor as well.